Hello to you all awesome and beautiful mindsetters. It is a lovely Monday and you know what time is it for? It is our Triple M Day where we learn much and learn more on our Mad Mindsetters Day. I am joined by Natasha, of course. How are you, Natasha?
I'm very well, Abraham. Good to see you back on a Monday.
Thank you. And before you say anything, happy belated birthday. I know that tomorrow, yesterday was your birthday.
Yes,
I hope you enjoyed it. Hey?
I did. Thank you.
I want to ask you, how old are you? Hey?
No, 15 again.
15 again. Nice one. It's a good thing when people grow. Even today, it's another Mindsetters special birthday. Indiana, she used to be a presenter. It's a birthday today. So
oh, wow. All
you were
good
nearly
people
born in the
March.
same day.
Yeah.
Well, there are so many people born in March, hey? Well, my birthday is next month. Otherwise, I hope the Mindsetters enjoy their day at school. Let me know, how was your day at school? How was your math class today? What are we doing today?
All right, guys, so today we're looking at inequalities. Last week we looked at solving equations. This week we're going to continue with solving things, but this time we're looking at solving inequalities.
Nice one. I've got so much to tell you, Mindsetters. Firstly, you can join us. Send us your questions if you're struggling in any way. If you have some questions, send them through to facebook.com/learnextra. Also use that page to help other Mindsetters, help your friends, refer your friends to Mindset also through that page. Otherwise, send us your tweets at learnextra. Follow us and let all your friends follow us too. And then lastly, download your notes for free on learn.mindset.co.za. Tell you what, as Mindset this week, from last week actually, we've started a campaign whereby we're saying walk together. It is a campaign whereby we're being sponsored by Tommy Techies, and you stand a chance of winning your awesome Tommy Techies, just like mine. Can you see them?
No, we can't.
They can. Look at these, Natasha. They're awesome. Look at this. And the nice thing about them, you can choose any color of yourself. So I've chosen white because it's a nice color. So if you like navy or red, just like you, Natasha, you can choose your color too. Otherwise, we have some winners from last week's campaign, because we're giving out 3 pairs each week. Every Friday we announce our winners. So we have our 3 winners from last week, and the names are Kanyisa Makanyi Jonga and Morongwa Enji Khatle and Caroline Ntsako. The captions that won were from Kanyisa: a journey of 1,000 miles begin with a single step, and she got 31 likes. Well done. And secondly, it was Morongwa Khatle, and her caption was, that's a soft, enjoyable walk together. She got 27 likes. And the last one was Caroline. Her caption was, the journey to my future is just around the corner. She got 18 likes. So all you need to do, Mindsetters, we have a picture that is posted on Facebook. Go to that picture, caption it with any caption of your choice, and then the caption with the most likes, it wins a pair of Tommy Techies. So congratulations, Mindsetters. Without any further ado, let's get to this lesson.
All right, great. Well, I'm glad everyone has their eyes on those tackies. Those look cool.
Yeah, they are. They're stylish. Unfortunately, we should have got one for your birthday.
We should have. Oh, well,
Next
time. All right, guys. So today we're looking at solving inequalities. Specifically, we're going to look at finding graphical solutions to linear inequalities. And we're also going to talk a little bit about interval notation. Okay, so our challenge question for today goes as follows. You are asked to solve for x, and you are asked to solve for x where 2 minus 3x is less than equal to 8 and greater than and equal to minus 1. So that's your challenge question today. Hopefully all of you get it. It's not a particularly difficult one, but it really puts all of the skills together that you would have learned thus far at school with inequalities. And if you want to, you can even take this one step further and maybe do a graphical solution for this challenge question. Let's see how many of you get that. All right. Now, guys, just to quickly go over and remind you guys what happens with inequalities, some of the key points and some of the key things that you need to remember. Firstly, when you divide or multiply an inequality by a negative number, you must remember to reverse the sign of the inequality. So if, for example, you look at something like 2 is less than 3, we know that on the number line that is true. 2 is less than 3. But let's look at what happens if I multiply both sides by negative 1. So say we have 2 times negative 1 is less than, all right, 3 times negative 1. So what I'm doing is I'm multiplying through by negative 1 and I'm keeping the sign as is. All right, but look at what happens. 2 times negative 1 will give me negative 2. If I do not reverse that inequality, I'm going to get negative 2 is less than negative 3. And we know that that is incorrect because on a number line, you always have an increasing negativity means a smaller number. So negative 3 smaller than minus 2. So therefore, if you do not, so if you forget to change the sign of your inequality, you will get an incorrect statement. You'll get minus 2 is less than minus 3. But we in fact know that minus 2 is supposed to be greater than minus 3. So therefore, a simple rule is that you have to remember to reverse the sign when you multiply or when you divide by a negative. Division would give you exactly the same thing. All right. Another thing that you guys need to remember is that if you take a reciprocal, now remember a reciprocal is an inverse of a number. So the reciprocal of 2 would be 1 over 2. So if you take reciprocals, that will also reverse the sign of the inequality. So for example, we know that 2 is less than 4, but if I took the reciprocal of 2 and the reciprocal of 4, all right, a half is what? Then a quarter? Well, you reverse the sign. So we know that 2 is less than 4, but a half is greater than a quarter. And that makes sense. A half is 0,5, a quarter is 0,25, 0,5 is greater than 0.25. So those are just little tips and rules and just reminding you really about the things you would have learned about inequalities. When you divide or multiply by a negative, you must reverse the sign. And then if you're taking reciprocals on an inequality, it's quite a tongue twister that. When you're taking a reciprocal on an inequality, you must also reverse your signs. Okay. Now I just want to also have a look, guys, at what we really mean. What is it that we're doing when we're solving inequalities? So let's have a look at this example. I just need to get my board to extend a little bit so all of you can see that. So I've drawn for you here the graph of y is equal to x plus 2. Okay, so it's just a straight line. You started learning how to draw straight lines in grade 9. So I've got the graph y is equal to x plus 2. Now say I asked you, where is the graph x plus 2 greater than 0? Okay, now you can actually look at the graph and decipher where this will be, or you can solve the inequality algebraically. Okay, but let's look at the graph and see what we're saying. We're looking for where x plus 2, which is your y values, because that's your entire function, where y is equal to x plus 2, where are all your y values positive? That's what that's saying to us. Where are all the y values positive? Now guys, what you need to always remember is, remember this is the origin. Everything at that point, the coordinates are 0, 0. Anything above your x-axis, all your y values are positive. All your y values below your x-axis are negative. So we've got positive y's above the x-axis. We've got negative y's below the x-axis. All of you know this, that you've been doing it for a long, long time now. So if I'm looking for where x plus 2 is greater than 0, I'm really looking for where the graph lies above the x-axis. Okay, so we're looking at all of this part here. Where's the graph above the x-axis? And we can see that that happens if we're looking at this point, minus 2. That only happens when x, your x values, are to the right of minus 2. If you look to the left of minus 2 in that whole part there, your graph is below the x-axis. And we're only interested for parts above the x-axis. Where is the graph positive? That's what the statement is saying. So therefore, if we were to answer this question just reading from the graph, we're looking at what x values would make this possible, and it would be wherever x is greater than minus 2. So everything to the right of minus 2. So therefore, our solution would be x is greater than minus 2, and that's simply reading from the graph. Okay. Obviously, if you guys solved the simple algebraic inequality, so you take the 2 over to the right-hand side, you would get x is greater than minus 2. So the same answer. All right. So that's really, when we're talking about inequalities, we're looking at what's happening. In this case, we're looking at linear inequalities. We're looking at what's happening to your linear function in terms of whether your y values are positive or whether they're negative. All right, so that's what we're really looking at. So if I were to then turn the question around and say, well, where is x plus 2 less than 0, what I'm really asking you in terms of a linear function is where your y values are negative, because x plus 2 is your function, right? So where your y values negative, you look at your graph, you see that all of the negative values for y, everything that lies below the axis, that only happens for all values less than minus 2. So there your answer would be x is less than minus 2. All right, so guys, that's what I want you to take from this. This is your summary, just to remember that when we're talking about linear inequalities, we're really examining what's happening to a linear function around a certain value that they give to you. All right, okay, and I think that's probably a good point to have a little break on before we come back and start our questions.
Thank you so much, Natasha, and a big shout out to all the Mindsetters that are on the page. Go tell your friends, your classmates, SMS them and tell them to watch Mindset Learn Extra on 319. Otherwise, if you have some questions and struggling, I'm here chatting to you on Facebook. Send those questions through on facebook.com/Learn Extra. See you after the break. Welcome back, Mindsetters. Now, looking at our Twitter, we have some tweets for you, Natasha.
Oh, okay,
It's a
great.
bit of a surprise. Are you ready for this?
Yes, give it to me.
Okay, here's the first tweet from Amukove Lipadzi. Happy belated birthday to the teacher.
Aw, that's sweet.
And I'm very happy that it's Monday, that Monday is finally here, because it is Maths for grade 10. And another tweet is from Zintle, Bianca. Happy belated birthday to our favorite mindset teacher. Hope God will
Aw,
bless
that's so
her
sweet.
with more wisdom and understanding to pass on.
That is just too sweet. That's the best birthday messages so far I have received, I have to tell you.
It shows how much we love you, hey?
Oh, thanks, Abraham.
Thank you.
I'm gonna cry.
All right. But now, on another serious note, there are mindsetters on the page, such as Banyana Mokhapane, who says, I just tuned in, but I'm stressing out for tomorrow's maths test. She's not the only one. Even other mindsetters are writing this week. What are some of the tips? I know we always say practice and practice and practice.
Yeah, that's it.
I know there's nothing more than that, but what are some of the tips that you have for the mindsetters?
Well, for starters, I mean, obviously you're writing your test this week, so it might not help you that much. But from next week, Abram, as you know, we've got some revision shows on mindset, which you guys always, they're so useful, so watch out for those. But really, my best advice to anyone at any kind of test is do past test papers. If you can't get your hands on past test questions, then make sure that you've gone through your classroom maths or whatever text you use at school, and make sure you've done all of the questions that you can from there. That's your best starting point, really, to get ready for the exams. And it obviously is that time of the term where it's almost the end of the term. I can't believe we're saying that, but it is almost the end of the term. So guys, good luck with the studying. But as I say, if you're not writing this week, maybe you're writing next week, then tune into the lessons from next week, Monday, where we'll be doing revision.
Exactly. And quickly, just one last note, adding on what you're saying. I think there's nothing that beats you seeking for help, because we always try and do things knowing very well that a certain subject or a certain part of the subject is difficult to you. Don't be afraid to ask for help, because there are people that understand it better than you. So it's always something that we need to work on. If you can't do it on your own, ask for help, and we're here also to help you guys.
Absolutely. So send your questions through today relating to inequalities, and we will try and help you guys later on in the show as well. But anyway, guys, carrying on with the lesson, Abram, if there's nothing more from that side, we're going to try and improve your skills with some of the questions on inequalities that I have. I think Abraham and them have put that up for you guys, starting with question 1. So here we are asked to solve for x and illustrate the answer on a number line. All right. So inequalities, guys, it's similar to an equation, to an equality, but obviously the inequalities implies certain other rules that you've got to bear in mind when you're dealing with inequalities. So if you understand equations, linear equations, it's really not a big stretch to move from linear equations to linear inequalities. And many of you have already gone way past this at school and you're probably thinking, oh, this is so easy, which is great. Okay, so let's look at 1a. We've got x plus x over 3 is less than 11 minus x over 2. Guys, whenever you're faced with denominators and fractions, you need to find an LCD. Here, our LCD between 3 and 2 is going to be 6. So we multiply our LCD throughout the inequality. Just like in an equation, once you found your LCD, you can drop it, provided it's not a variable. And in your case, it's not going to be a variable in this section just yet. So our LCD is 6. We times through by 6. We're going to get 6x. So I'm timesing the first term by 6. We times the second term by 2. So I'm going to get plus 2x is less than 11 times 6 is 66 minus 3x. Okay, guys, so I'm not putting that step in. All I've done is I've times through by my LCD of 6. Okay, so we got rid of the LCD. All right. We then, like you would in a linear equation, you collect all of your variables onto one side. So 6x plus 2x will give me 8x. Bring the minus 3x across, so it becomes plus 3x is less than 66. So 8x plus 3x will give me 11x is less than 66. Divide both sides by, whoopsie, divide both sides by x, by 11, not by x. Alright, so divide both sides by 11. So we get x is less than 6. Alright, so we've got x is less than 6 from the inequality that they gave us originally. But remember, you're not done, because they also say illustrate your answer on a number line. So guys, this is a very rough sketch. You don't have to now go and take a ruler and measure 6 units and all of that. You really just, okay, let's see if we can extend this page. There we go. We're really just putting in a rough illustration of x is less than 6 on the number line. So I'm going to say that's 6 there. X is just less than 6. So I use an open dot and show that it's everything to the left of 6. Now that we've gotten to that point, in fact, let me just make that a little bit more clearer. Let's discuss the open circle and the closed circle. So here we're going to have an open circle. So I've got x is less than 6. Now remember, guys, when you're dealing with just a less than or just a greater than, you're not going to have a closed dot when you're representing your solution. So if you look at the number line I've just got x is less than 6, and we just have an open dot above the 6. So at this point, let's just mention that an open dot means not included. Okay, so x was just less than 6. It wasn't equal to 6. And a closed dot would be included solution. So if I had x is less than or equal to 6, we would then have a closed dot above the 6. All right, so your open dots is to show not included solutions, closed dots show included solutions. All right, hopefully you all follow that. Okay, in part B, okay, and I'm going to try and do this with as least amount of mess as possible, because it's a bit of a weird one to try and fit in here so that I can see the whole sum. Again, guys, we've got an LCD here of 16 in this case. So the first step is to get rid of that denominator by multiplying through by 16. So I'm going to do this at the top here and then bring this all down to the bottom. My LCD is 16. I'm going to multiply the 3y by 16. Minus 4y plus 4, we're going to keep that in brackets because we must remember to multiply the negative into the brackets. And on the right-hand side, we're going to multiply by 4. Okay, so my first term is going to become Okay, so I'm going to get 16y minus, I think it was 4y, but as you all know, I'm getting older since yesterday, so let's just double check that. It's going to be minus 4y minus 4 is greater than, let's go back up, and we're going to times the 4 by the 3, so we get 12 into y minus 1. So we're going to multiply that into the brackets, so I get 12y minus 12. Okay, so let's just go back up there. I found an LCD of 16, multiplied the first term by 16, so I get 48y, multiply the negative into the bracket, and then times the 4 into the bracket on the right-hand side. Okay. All right, now that we've got it in this form, we do the same thing as we did before. We collect all of our variables onto one side. 16y minus 4y is 12y, all right, and we're going to get minus 12y is greater than minus 12 plus 4. So I get 12y, is that right? 16y, not 16, made a mistake, that was supposed to be 48. I was wondering what's happening, all my y's are disappearing. 48y minus 4 is going to give me 44. 44 minus 12. There we go. So let's change that. So 48 minus 4 is 44y minus the 12y that I bring over is greater than minus 12 on the right-hand side. Take the minus 4 over, so it becomes plus 4. Okay, guys, so the mistake I made there was I forgot to multiply the 16 by the 3 to get 48. Okay. Hopefully, and I'm sure, I mean, you guys are so sharp. I'm sure they spotted that, Abraham. Okay, 44 minus 12. I wonder if my old brain can take it. Let's subtract it just to double check. Smart ink. Let's try and close that. Okay. Turn it off. There we go. Let's turn that off. There we go. Let's try again. 44. Would have been quicker to just do this in my head. 44 minus 12 is 32. So we've got 32y is greater than minus 12 plus 4. That gives me minus 8. Divide both sides by 32, and I get y is greater than minus 1 over 4. Because I would get 8 over 32. 8 goes into itself 1 time. 8 goes into 32 4 times. All right, so we end up with y is greater than minus a quarter. Okay, so all the values to the right of minus a quarter. So to put this on a number line, we're going to have minus a quarter there. And it's just greater than, guys. So this is what I was saying. If we don't have an equal to sign, we're going to start with an open dot. It's everything. And how I remember which way, okay, if you don't really get, I mean, if you understand greater than, great. But for those of you that can't understand which way the arrow is supposed to be going and which way the line is supposed to be going, what I always say to my students is, look at the arrow or look at the sign of the inequality. That should be the direction in which your line points. You see? So that's arrow. I keep saying that arrow. This inequality is pointing to the right. That means that my line with my arrowhead needs to point to the right as well. So y is greater than minus a quarter. Okay, so let that be the indication of whether your line and your arrow needs to point to the left or to the right. Okay, that's for those of you who are struggling to understand what the sign is saying. All right, and you don't understand the crocodile thing and that, then this the arrowhead is a nice way for you to remember. Okay, so that's the graphical solution to that inequality. And remember, what I showed you in the beginning of the lesson is when we're dealing with linear inequalities, we're really talking about graphs, linear graphs, and you know, according to the graph, what is happening? What have they asked you for? Is it greater than a number? Is it smaller than a number? You can bring everything back to your linear function, and we're looking at what's happening to the y values around a certain point. Okay, all right. Let's carry on improving our skills. This is now question 2. And here we're going to tackle interval notation. Okay, so let's discuss interval notation before we actually have a look at the question. Now, a lot of you, as soon as you see interval notation, and it's a good thing if you do this, as soon as you see interval notation, you think of interval notation, you think of square brackets and round brackets. Okay? A round bracket implies, let's just take that out. Okay. Alright, so a round bracket really just implies not including that end point. Okay, so a round bracket, very similar to your open dot, it indicates a value that's not included. Your square bracket, very similar to your closed dot. In fact, it's exactly the same thing. It means that that end value is included. So that's including your last point, and that's excluding your last point. Guys, what you need to remember about interval notation as well is because we're talking about a period over a number line, whenever you're giving answers in interval notation, your answers for x or y or whatever variable are spanning that entire period. So what that means is all your answers are going to be real numbers. So, for example, if x is between -2 and 1, we're talking about all the values between -2 and 1. So there you're going to have like a half, you're going to have 3/4, you're going to have all the fractions, everything included in that interval. So as soon as you ask to do interval notation, you automatically should be realizing that you're dealing with real numbers. If your question then stipulates, like in this question it says x is an element of real numbers, that's fine. But if your question stipulates, for example, x is an element of natural numbers, or x is an element of whole numbers, or x is an element of integers, you can't then give your solution just with your square and round brackets. You then have to give specific values. And I'll show you maybe a little bit with this question what I mean there. Okay. All right, let's have a look at this question. We've got to solve for x. We've got -2x plus 3 greater than equal to -3 less than 11. They tell you x is an element of reals. They tell you you're going to use interval notation, so that's fine. We're looking at all the real values in whatever period we get at the end. First thing, guys, it looks confusing, but you're just going to split it up, right? You're looking at just the inside thing, just the -2x plus 3. We want to get to a point where we're going to have x is less than something, x is greater than equal to something. So we need to strip away everything else that's joined to the x. First thing we're going to do is get rid of the positive 3 by subtracting 3 on both sides. So I get -2x is less than 11 minus 3 is greater than equal to -3 minus 3. So I've taken the 3 away on both sides. When your expression is included inside your inequalities like this, remember, you can't just subtract on the one side. You've got to do it throughout the inequality. So I've got to subtract the value of 3 on the left-hand side as well. Okay. So I'm going to get -6 is less than equal to -2x is less than 8. Okay. We then going to get rid of the -2. Now this is where the very first, the summary we did comes into play. When we divide by a negative, we reverse the signs. In this case, we're going to reverse both the signs, the less than and the less than 8 and the greater than -6. Okay. Divide through by -2. Change your signs around. So I'm going to get 3 is greater than or equal to x is greater than -4. Okay, -6 divided by -2 gave me 3. 8 divided by -2 is -4. So I've got 3 is greater than equal to x, which is then greater than -4. Now, a lot of you might get confused at this point because it's not in the way you recognize with both your inequalities facing the left. All right? all you do, guys, is you can rewrite this. So if 3 is greater than or equal to x, x is greater than minus 4. Really what we're saying is the solution to x lies between the smallest number and the biggest number. So x is greater than minus 4 and less than or equal to 3. So this is the same as that. Okay, that's exactly the same thing. These two things are equivalent. Okay, so x is greater than minus 4 but less than or equal to 3. So whenever you're dealing with an inequality, your smaller number is going to be on the left-hand side, your bigger number is going to be on the right-hand side if you have your variables squished in the middle. Okay, so when you're getting your solution at the end, you're going to have, if we're dealing with your inequalities facing to the left. Do you see what I've done there? I've turned them around into something that you guys are more familiar with. You're used to having it with the x in the middle, and then we've got a greater than the smaller number, and then a less than the bigger number. If you're going to do it that way, you can turn any inequality around, make it something that you understand. You just need to remember, if you write it in this way here, you need to have the smaller number on the left-hand side, the bigger number on the right-hand side, and then your x in the middle. Okay, just make sure you don't get confused with those signs there where they're facing to the left, and then those ones where they're facing to the right, because they mean exactly the same thing, but some of you, I know, can at times get confused with what it's saying to you. Okay, all right, so just be careful with the way you write that out. All right, so I've rewritten it. It means the exact same thing. X is less than or equal to 3, greater than minus 4. They said write this answer in interval notation. So if you give the answer and you finish off there, you're losing some marks, right? Because we need to now write this as x. Whenever we write interval notation, we start with x is an element of, we start from the smallest number, and we're starting at minus 4. So x is an element from minus 4 up to and including 3. Okay, so x is an element from minus 4 up to and including 3. And it's all the real values that sit between minus 4 and 3. So it's all your fractions. It's everything that sits in that little interval. All right. Hopefully all of you have got that. Please don't make the mistake of not putting your inequalities the right way around so that it makes sense to you. And don't make the mistake of leaving your answer just with your inequality signs in it. You need to go that step further and understand that if you're talking about interval notation, you need to use your round bracket to show that it's not included, and you need to use your square bracket to show that it is included. Okay, I think this might be a good point for us to have a quick break before we look at the rest of the questions.
Yes, it is. And Mindsetters, I see a lot of questions from you. Keep them coming, and let's help one another also on the page. The picture is posted on the wall for the Tommy Techies for you to caption. Otherwise, see you after this break. Welcome back. So many sweet messages and inspiring messages on Facebook. I love them. Keep them coming. Mindset is saying you enjoy the show and you enjoy the subject. But above them all, there's just this two that killed me. The first one is from Hester Homoto. Happy belated to our lovely mindset teacher. God bless you more. With sweet. Many brain cells to teach us maths. Hope you enjoyed your day. And another one, wow, this teacher explains very, very well. I like that maths time. Enjoying the show big time. That is Tammy Tamsang. Thank you so much, Mindsetters. Keep your questions coming too. Thank you,
okay. I think without that, without further ado, it's time to get back to the questions. I want to try and get through to the challenge question as well. Thank you guys for all the sweet messages, and I'm glad that you are understanding. That's always good to know. Okay, so question 3 could possibly have been the challenge question. I would actually be eager to know if you guys did attempt this in Improve Your Skills, and if any of you got the right answers. Let us know what your answers are. This is for question 3 in Improve Your Skills. Okay, so here we asked to solve for x, and we've got ax minus bx is greater than 2a minus 2b. In part A, they tell you if a is greater than b. All right. Now, the first thing we need to do is to make this look similar to something that we know how to deal with, okay? So the first thing I'm going to do is on the left-hand side, when I've got ax minus bx, I'm going to take out bx as a common factor. So I'll be left with a minus b is greater than, and then on the right-hand side, I'm going to take 2 out as a common factor, and I'll get a minus b. Okay. Now, a lot of you at this point will say, hey, hang on, well, there's an a minus b, there's an a minus b. Let's cancel these 2 out. Let's divide it through. But guys, remember, you can't do that, because now we're not just dealing with an equation, we're dealing with an inequality. So if we're looking at an inequality, dividing or multiplying by any kind of number is going to change the sign of your inequality if you don't know whether that number is positive or negative. Okay, remember, when you divide or multiply by a negative, you reverse the sign. So we need to be told something about a and b in order to simplify this a little bit further, right? So here in part A, they say, what happens if a is greater than b? Well, if you look at what you've got, right? I've got a minus b in this bracket. If I have a is greater than b, that's going to turn this expression, a minus b, into a positive expression. Okay? The reason for that being, think about any number you want to at all, a is where a is greater than b. So for example, 4 is greater than 3, right? In that case, 4 minus, if this was 4 minus 3, I'm going to get a positive answer. You can take any number at all that you can think of. It'll always work where a minus b will be positive because a is greater than b. Now that I know that this expression is positive, I know, this is part A, that if I divide through by a minus b, it will not affect the sign of the inequality. So I'll get x is greater than 2 into a minus b divided by a minus b. And as you can see, the inequality will stay exactly the same because we know this is positive. So the a minus b's cancel, and I just get x is greater than 2. Okay, so that's part A, x is greater than 2. Now in part B, they tell you that a is less than b. Similarly, you'll have a look at what happens to your expression. If we're looking at a minus b, and a is less than b, so any numbers, again, let's take the number 6. A is equal to 6, for example, and b is equal to 7. Okay? If you're going to put in a number smaller than the b, you're always going to end up with an expression a minus b being negative. You always will end up with a negative number. So therefore, when you're dividing both sides, in this case, by your a minus b, your sign will have to turn around. It will have to be reversed because now you're dealing with a negative expression for a minus b. Okay, so there in part A, we left the sign as greater than, but in part B, we need to reverse the sign of the inequality because a minus b was negative. So here you'll get x is less than 2. All right? And then part C, they tell you that a is equal to b. So again, we're using that same expression, but now we've got that a is equal to b. So I've got x into a minus b is greater than 2 times a minus b. Now guys, if a is equal to b, this expression, a minus b, is going to become, if they're equal to each other, so they're both a or they're both b, we're going to get, this is equal to 0. So if that is equal to 0, when a is equal to b, this term on my left-hand side is going to become 0, because x times 0 is 0, and that term on my right-hand side is also going to become 0. So I get 0 is greater than 0, which is not possible, because 0 itself is 0. So therefore, there's no solution for that last part, if a is equal to b. All right. So guys, hopefully you all got those answered. As I said, I hope that you've got those answers. And Abraham, has anyone answered question 3?
Maybe they're gonna give me the answer.
Okay, hopefully you guys
Please
answered.
post it on
and
the
you-
wall, mindsetters.
Yeah, hopefully you got these answers because it's a nice trick question for an exam or test situation, especially for those of you who are writing this week. All right, so I'm about ready to start with the challenge question now. Do we have any takers on that? Do we have some people who've answered that?
Let me look for it. As you do it, I'll let you know.
Okay, all right. So guys, let's hope that you guys got this answer. And then remember, in the beginning of the show, I said, let's take it one step further and say, write your answer or illustrate your answer on a number line. Okay. So we've got -1 is less than equal to 2 minus 3x is less than equal to 8. All right. So guys, as I said to you in the previous example, a similar example, we want to strip away everything from the variable, get rid of whatever is not the variable itself. So the first thing we need to do is take the 2 over to the left-hand side and then to the right-hand side on that side. So we get -1 minus 2 is less than equal to minus 3x is less than equal to 8 minus 2. Okay, so I've moved the -2, I've subtracted it on both sides of my inequality. Remember, when you're subtracting or adding negative numbers on an inequality, your sign will not change. All right? So on the left-hand side, I get -3 is less than or equal to minus 3x is less than or equal to 6. Okay? Now here, this is where you've got to be careful, because now we're going to divide the inequality through by a negative. So when you divide through by a negative, the sign of your inequality, that's the most important thing you're going to take out of today's lesson. When you divide by a negative, the sign of your inequality needs to turn around. So I'm going to get 1 is greater than or equal to x is greater than or equal to -2. So in other words, x is greater than equal to -2, less than equal to 1. That's really what that means. So x is between your two endpoints of -2 and 1. All right, to illustrate this on a number line, for those of you who prefer your signs to face the other way around, okay, if you want to rewrite this, it is not essential that you do, but I'm just doing it for those of you who prefer to see things the way you've always learned them. If you want to turn your inequalities around, okay, it's the same as saying x, so this is the exact equivalent solution. X is less than equal to 1 and greater than equal to -2. Okay, so if you want to turn them around and you prefer to see them this way, by all means do that, whatever you understand a little bit better, right? Now I said we're going to show this on a number line. So we're going to have the values of -2 and 1. Okay? And in this case, we've got x is greater than equal to -2, so we've got close dot. X is less than equal to 1, close dot again, because we're including the endpoints. So we have x is between -2 and 1 on your number line. We can take it one step further and write the answer in interval notation. So that's the graphical solution, or illustrated on a number line. And then we can go one step further and say in interval notation, we can have x as an element, and in this case both our end values are included, so we open a square bracket and close square brackets. It's between -2 and 1. All right, and guys, remember, as I said to you before, when you've got x as an element from a number to a number, all of the numbers inside here are real numbers. Okay, Abraham, do we have anyone who had that answer of x is less than equal to 1, greater than equal to -2?
Let's see. The mindsetters have tried. I think there is someone with that answer. I think there is that answer.
All right. Well, hopefully they all got
and
it.
thanks to everybody that tried out.
Yeah. So guys, as I said, I've shown you the number line solution. I've shown you the interval notation for this specific question. And I'm glad that some of you have tried it. And even if you've failed to get the right answer, hopefully you now understand and have learned where you went wrong. All right. Abraham, do you have any other questions?
Yes, we do. The first one is from Ratu. On the very first question, she says, I don't understand question 1 clearly. How did you remove the denominators?
Question 1, okay, so I'm just going back to there. So for question 1, we had to find an LCD firstly to get rid of our denominators. So if we're talking about question 1A specifically, we saw that our LCD was 6. Okay, that's your LCD between 3 and 2. That's the number that both of them will divide into. So therefore, when you find an LCD, remember you're multiplying each term by what it doesn't have in the denominator to get it to that common denominator. So what I'm saying is, for your first term, you've got x over 1, right? So the 1, in order to get from 1 to 6, what do you have to do? You multiply by 6 over 6. All right? For your second term, you find your LCD of 6 again. So to get from my 3 to 6, I need to multiply by 2 over 2. 11 is over 1, so I want to get to my LCD of 6, so I times by 6 over 6. And then the last term is over 2, so you times by 3 over 3. And what I did was, I did it very quickly because we have gone over fractions and that before. I did it very quickly, and I didn't show the step where I put everything over the same denominator, but I'm basically doing exactly the same thing as you would normally do when you add your common fractions. All
Thank
right.
you. Another question is from Sanele. Sanele says, well, firstly, I'd love to wish you a happy birthday to our teacher today. I'm still having problems, though, with factorizing the difference of 2 squares.
Okay, that's a completely different section.
Though you sent a message.
Yeah. Okay, well, thank you for the birthday wishes. Now, difference of 2 squares is a completely different section, and I don't want to veer off into that section, which we have done, I think, about 3 shows ago. But the good news is that if you watch next week, Monday, I think it is, they will do revision shows, and they will show you how to do difference of squares. Remember, you can also get the notes online. Hey, Abram.
Yes, so
you
true.
can get the notes online, and you can download that specific episode on factorizing. But we certainly, unfortunately, don't have time to start doing that whole new section. Yeah.
All right. Thank you so much, Natasha. There was a question on Twitter, also based on the first question. Mindsetters seemed to be confused on how come our 4 remained positive
Right.
when we moved it to the other side.
Right, okay. Now this was something I showed you guys in the beginning. Now what he's asking there is, why did this positive 4, when I took it to the other side, become positive 4? Because what you might have done there, Mindsetter, is you didn't times the negative into the bracket. Because if you multiply that negative into the bracket, you're going to get negative 4y, negative 4. So when you take it over, it's not staying positive, it changes to a positive when you take it over to the right-hand side, because you had to remember to multiply that negative into the bracket, which would change the 4 to a negative, and then when you take it over to the right-hand side, it then becomes a positive. So I think that was the mistake there.
Exactly, and I think is it the same thing that happened on 1B also?
This is 1B, yeah.
All right.
Yeah.
Okay, see. Well, thank you so much, Natasha. That's where we have to end it today.
All right.
Here's a comment though before I end it. Togozi Sinkawinde says, wow, looking good in those tummy techies, eh? Thank you so much. They're so cool. You could also win a pair. You just need to caption the picture that is posted on Facebook. Get all your friends to like it, and let's like one another's caption, Mindsetters. Let's support one another. You'll never know. Then the highest Mindsetter with the most likes on their caption, they get to win a pair of tummy techies of their choice. Otherwise, Natasha, thank you very much.
Thank you so much, Abraham. It's been great being with you guys for the first term. Please stay tuned next week when we do revision lessons, and I'll catch you in the new term.
Thank you so much, and thanks for the present of teaching us, though it was your birthday. Otherwise, Mindsetters, we'll see you some other time. Great hands. Keep it tuned in on Learn Extra, where you learn more and learn extra. Peace.